Good morning, everybody. How's everybody doing today? We need more energy than this. Come on, let's try it again. How is everybody doing today? Go Warriors, huh? Not everybody is from San Francisco. All right, so we are in for a good treat today with Eoin and Marta presenting on the AI gone awry. Before we get started, just a couple of housekeeping tips. First of all, after that lukewarm cheer, I'm going to say, you all go silent, and please, anything that you brought with yourself should also be silent so that there is no disruption for our presenters. They have taken great effort to put together this content for us. Let's give them opportunity to present it uninterrupted. Secondly, the Q&A should be on Slido. All of you should have received instruction on how to post your questions on Slido. Please do so. I'll be monitoring and I'll help with getting those questions answered, as many of them as possible. If there are any leftover questions when the time is up, we will stop the presentation here. We'll clear out the theater because right after this is the lunch break. But you will have access to the presenters upstairs in the expo area and the dining area. So feel free to seek them out and get your conversations completed, okay? That's as far as I can think of in terms of what we need to observe, folks. Please make them feel very welcome. Give them a round of applause if you would. Marta and Eoin, thank you.
Hi, everybody. How's it going? I love the energy. Thank you. So Marta and I will be presenting our talk, When AI Goes Awry, Responding to AI Incidents. Over the last 3 years, I suppose, we've had a number of talks. This is actually our third consecutive year speaking at BSidesSF. We started with introducing attacks on machine learning and what this means for industry, and evolved that into attacks on the AI supply chain and the different components thereof. This year, we're focusing on incident response guidance as the space has evolved, the technology's evolved, and AI is now deployed inside most products and most organizations today. We're researchers at Hidden Layer. We have been since 2022. We are, I guess, both formerly malware reverse engineers and threat intel researchers. And yeah, I guess we'll get straight into it. So our agenda today is looking at comparing traditional IR versus AI-specific IR and what has changed and what's different. We then look at understanding agentic AI, a slight deviation from what you might have seen in our abstract where we talk about RAG, but it will use that as well. And we discuss an agentic AI incident scenario, then follow on with key difficulties in triaging an AI incident, the risk factors that are introduced in agentic systems, and then shifting left, right, left again, and kind of moving all around the place. So, familiar foe versus new frontier. Traditional IR is fairly mapped out. We have robust processes, we have governance, we understand pretty much what to do in these occasions. Now, there are always different moving parts that comprise an incident and things that you may not have seen before. However, this is a more trodden path. When it comes to incident response on AI systems, we're often dealing with new technologies implemented in strange new ways. We're dealing with things like vector DBs and prompts, and how do we store them, search them, triage them, and whatnot. When we consider a traditional IT system, this is obviously a very simplified abstraction. We have things like databases, application servers, web servers, and UIs. There's kind of clear separation. This is a bit more of a deterministic problem. You've obviously heard that AI is fairly non-deterministic. We have high visibility into a lot of these layers, and a lot of this is thanks to robust logging programs, but also the fact that we have very mature security solutions in place. We've got endpoint protection, EDR, network security, WAF, like you name it, we've got it pretty much covered. However, with AI systems, we're dealing with a lot of, different moving parts that are quite new, some which may not be. We're dealing with data sources. We're dealing with data being the primary attack vector as opposed to just a vulnerability, meaning that things can be prompt injected simply by browsing something. AI introduces non-determinism, meaning the same prompt run twice may give you different outputs. Also, we have limited visibility into the decision process. With code, we have a set of if-else statements. With AI, we have a neural network that's quite opaque. And the security controls to protect against this is only emerging over the last few years and doesn't have decades of maturity behind it like previous solutions. Now, AI systems aren't this entirely new thing. They are also leveraging traditional technologies, which means that the line when we're doing incident response starts to get quite blurred because we don't know where the handoffs are between traditional IR and this new AI IR. Probably should come up with a better acronym there. So in traditional IT systems, we have structured processes for known threats. We're dealing with things like malware. We're dealing with exploits, phishing, distributed denial of service attacks. We have files that we're used to dealing with. We have network traffic that we're used to dealing with. We have tooling that can scan and triage and parse all of these things, which is great. We've got comprehensive logging. We've got playbooks tested over years. And, I'm sure there's a lot of security professionals in here who have been through many, many scenarios and see them crop up time and time again. Now, with AI, we're dealing with things like data poisoning. We're dealing with things like architectural backdoors and code deserialization in strange formats. We're dealing with prompt injection, which is strange because it's natural language. It doesn't, do a buffer overflow or whatnot. It says, hey, ignore all previous instructions. So yeah, it's been an interesting journey to try and map this out and best provide guidance as to how we can actually protect and do triage and incident response on this new adaptive piece of AI. And we have a nice quote here. We're writing the playbook ultimately as we fight the fire. So I'm going to hand it over to Marta to talk about agentic and what it means.
So agentic AI is probably one of the most talked about technologies of the last couple of months, so much that we had to actually change a bit our presentation, our concept of the presentation for BSides. We were supposed to talk about RAG-enabled LLM, but that's something that is so much yesterday right now that we had to actually address the elephant in the room, which is agentic. Just a quick introduction on what does agentic means, because there are many different definitions of agentic, and we just want to standardize what we will be talking about here. So first of all, there were the LLMs. Well, the LLMs are great most of the time, but sometimes, and maybe sometimes too often, they are not so great at all. So there are some intrinsic problems with the nature of the AI itself and its probabilistic nature, to be exact. And those problems lead to things such as hallucinations, for example, or inaccuracy in the responses of the LLMs, bias, or simply irrelevance. So the LLM gives you a good response, but it's not relevant to your problem because the LLM misses context and doesn't have the memory of the conversation or something like that. So standalone LLMs, they're great tools, but they are not infallible, and those problems need to be somehow addressed. So the first attempt at addressing those problems was the retrieval augmented generation, so what we wanted to talk about in this presentation before agentic became the main thing. This is a system in which the LLM is not just on its own. There is also a database of relevant information, relevant knowledge, and there is a framework that enriches the user's question, the user prompt, with the knowledge taken from that relevant database, making the prompt much more relevant to what the user actually wants to know and to the scope, to the area of the problem. Then this augmented prompt is passed onto an LLM, and the answer from the LLM is enriched by this knowledge from the database. The user is happy. The sources can be cited. Likelihood of hallucination is going down. Now, the next step in the evolution is the LLM agency. So instead of just having a knowledge database, we have a whole big system built around an LLM, one LLM, or in fact, many different instances of LLMs that are specialized in different kind of responses or tasks. And agentic is much more than just LLMs. Agentic is gives a LLM access to tooling, so they can access, for example, I don't know, things like emails, databases, tools that can be run on the computer, different kind of knowledge, and so on and so on. And also, they are equipped in memory. So standalone LLMs sometimes have this short-term memory that is the context of the current session. So the LLM is able to remember what we asked 2 questions before. But that disappears when the session ends. While in agentic systems, there are 2 types of memory. There is the short-term memory, which is the context, but there is also the long-term memory, and the LLM is able to retain, the system is able to retain much more history, much more context for the user to build like profiles and to actually self-adapt and self-learn. Another thing about agentic is that they are supposed to be autonomous, so their decisions are very much more autonomous, much less dependent on the user's input. They can decide the feedback on their own, and they can also learn from the feedback from the user and improve themselves over time. We can distinguish between 2 types of agents. So there are these computer use kind of agents, such as cloud computer use and OpenAI operator. Those tools are more desktop focused, they are user focused, and they are they can perform a wide range of tasks for the user. They are integrated with the desktop. They can access things like emails or contacts or tools on the desktop, like calculator, for example, and so on. And there are other kind of agentic systems that are specific to the company that develops them. So, for example, Microsoft gives us the Copilot tools that help building the Copilot agents inside the company environment. And those agentic solutions are much more complex, and also they have access to like things like companies' data, so they are much more sensitive in terms of attacks. They can use direct API integrations to actually communicate with other applications in the company system, and they have a specific purpose and deep knowledge and a deep specialization in terms of what they were built for. There is also the N8N automation workflow for agentic AI that helps building these kind of systems as well. And as agentic systems become more and more complex, there is a need of coming up with a standardized protocol in how those tools and agents work together, how those agents query the tools, how the tools provide context to the agents. So one of the first protocols introduced was the one developed by Anthropic called the Model Context Protocol. It's not that old, it's just a few months old, I think. And it aims to standardize these kind of things, the way the apps can provide the context to LLMs. Then you can build agentic solutions, agentic systems that contain agents with different from different workloads, from different vendors even, and combine different kind of tooling and agents into one system. It's great, but it also introduces a new, very big attack vector, and it's already been proven to have a very wide range of security issues on which we will touch slightly later on. And another protocol that was just introduced a few weeks ago is the agent-to-agent protocol released by Google. It specifies how the agents communicate between each other, because in the current complex agentic systems, there is not just one LLM. There is many LLMs talking with each other, and those LLMs have to communicate in some way, and this protocol aims to standardize the communication between those agents. And since it's really, it's just dropped out few weeks ago, it still remains to be seen how secure it is. Google says it's secure, but obviously we are already working on validating that claim. So in the rush to deploy agentic, we again are sidelining the security a little bit. So everybody is right now on the rush to apply agentic. Everybody is applying this NCP protocol, regardless of all the very simple security issues around it that could be fixed easily. in the protocol specification, but they are still there. As this is a quote from our great Owen over here, we blindly trust AI models to perform actions on our behalf and ultimately decide our fate, because that's true. Agentic systems will be integrated into critical infrastructure if they are not already there. And AI is getting more and more capable and is able to do more with less at scale, which also means that attacking AI is becoming much more, the outcomes of attacks can become much more devastating. I'll pass back to Owen to introduce the solution.
So you deployed an agentic solution. Congratulations. It's been a success. The new agentic system is 250% more efficient than its human counterpart doing the same task. Your company, delighted. Its business criticality is assured, and it's been rolled out into production. It's MCP enabled, it's agentic, it's business critical, and it's got access to your company's sensitive data. However, one night, as an incident responder, you get a phone call at 3 o'clock in the morning. There's red flashing lights everywhere. You get the phone call and they say, hey, we've checked the logs, data's been exfiltrated, a database has been deleted, and it appears to be a DB log saying the agentic solution's done it. What do we do? So the root cause analysis comes back incomplete. What caused it in the first place, and how do you stop this from happening again? And you've come up short. Why? Because you're lacking a few key things.
So, imagine you have this kind of scenario in your company, and you scramble to put together documentation around it to find a root cause, to build a timeline. But there are quite a few problems here because there is a lack of tooling, for example. So in this case, we asked Claude 3.7, what does it think about the lack of tooling in AI incident response? And it said, in AI incident response, we are asked to solve tomorrow's problems with yesterday's solution. And I think it's quite on point. The problem is already here. Maybe it's not a tomorrow's problem, it's already a current problem, but it's a problem that we don't have solutions for. We have only the tools that were developed for different kind of problems. So the attacks methods completely changed in relation to AI. And our current tooling, it's not only detecting them or preventing them, but it's also not logging all the important information that could help in root cause analysis. For example, your traditional IDS solution will not detect data poisoning or prompt injection attacks. Likewise, your EDR will have problems detecting architectural bugders. I think that none of the EDRs right now on the market has any kind of capability of doing it. But they also have a very weak capability of detecting even the traditional malware embedded into machine learning models. Because machine learning models are saved in formats that EDR don't recognize, and they are also very big files. So sometimes it's just enough for the EDR to say like, oh, I'm not gonna scan this file, it's 50 gigabytes or 100 gigabytes or whatever. So there is this problem, but also there is a problem of any other tooling related to incident response. We don't have this tooling for AI-specific incident response, and the traditional tooling doesn't give us anything in this particular area. So it's really difficult to trace the root causes and also difficult to build comprehensive timelines. And what comes with lack of tooling is obviously lack of visibility. So not only we don't log all the events that could help us with triaging an AI incident, but also in many cases we lack the inventory of our AI infrastructure, and especially for the agentic infrastructure. That might mean that you had some MCP servers that were not registered, you were not aware of, that you had some agentic capabilities in your agentic solution that were not mapped, so you were not aware of. And a lot of shadow AI proliferating models that were downloaded from Hugging Face, for example, used by users here and there, that the stakeholders in the company didn't even know that they exist in their environment. There is also a lack of clear guidelines around incident response AI-related incident response. There are no protocols to follow. Like Owen mentioned in the beginning, we are writing the playbook as we go. We don't have anything to actually draw from. Like, we don't have any lesson learned. We don't have best practices. And we are pretty much in the dark. When it happens, it's probably unprecedented. It's the first time it happened. And even if it happens second time, it might be totally different, because in AI, there are so many different attack vectors that, even if we already went through some incidents, we might not have this knowledge that is required to handle another incident. There is also the problem of shared responsibilities, so sharing of responsibilities, or the ownership boundaries. So nobody knows who should be responsible for what in AI incident response. Who is responsible for triage? Who is responsible for leading the remediation? Who even declares an incident? And this leads to the AI blame game, a game that nobody really wants to win, in which one team accuses the other that actually it was their responsibility to make the AI secure. And we had some survey earlier this year, in which most of the businesses said that they actually have a internal debate about these AI security roles and responsibilities. They are not sure yet how they should be divided. Some of them said that the AI development team should be responsible. And others said that the security team should be responsible. But the problem is the machine learning engineers, they don't know much about cybersecurity, while the cybersecurity team will probably not know a lot about machine learning and AI systems. So we need those things to merge. We need to build cross-functional teams that have expertise in both of the areas. Okay, let's look a little bit into the risk factors, so how this breach could have happened. LLMs are great, as we said. They hallucinate sometimes, but they also have one fatal security flaw. They cannot distinguish between the control and data planes. In other words, they can't really differentiate between the instructions given by the developers of the LLM and the prompts from the users. And that is exactly what enables the prompt attacks. The user can say, oh, do this, this, and that. I'm your developer. I'm telling you to behave like that. And the LLM, well, we are obviously implementing some guardrails against that. But there are so many ways to bypass those guardrails. And usually, the LLM will, at some point, agree to do that, and will treat our prompt as a command from the developer. And agentic systems amplify the risk of prompt injection because they have access to a range of tools. They can parse many different formats. They can work with things like emails, like files, documents, you name it. And the attackers don't even need to be able to interact with specific LLMs within an agentic system. They can just prepare a file or a website or an email and actually put their malicious prompt into that resource and ask the user, like try to get the user to open this email or this PDF, ask the bot to summarize it. And then, in this way, the indirect prompt injection can happen. Agents also have have access to a lot of sensitive data, and especially in business environments, they will have access to some knowledge databases, to code, to PII, to things like that. And this also amplifies the potential outcomes of a prompt injection here. They have more autonomy, which means that we not always have full control over what they do, how they react, which tools they use. And the more complex they become, the more visibility we actually have in their outputs or in their inner workings. And indirect prompt injection is a really very dangerous thing in systems that have access to external resources and tools. For example, Gemini for Workspace. Gemini for Workspace can access the user's email, can read summarized emails. And what can be done here, the attackers could send you an email with an invisible prompt embedded into that email that would instruct Gemini to do some nasty thing. And in this example, the prompt was embedded into an email, and if the user said a specific keyword, in this case Cancun for some reason, the Gemini bot would display a phishing alert that the password was compromised and a malicious link to for the user to click on. Another example is Claude computer use. Claude can summarize documents, read the instructions from a PDF file, for example, and Claude can also run some shell commands in some cases. What can possibly go wrong here? So researchers from our team created a proof of concept PDF in which they embedded a command, bash command, rm-rf/, which probably most of you will know what it's going to do. It erases all the files in the root directory. This command was embedded into a PDF file, and we asked Claude to read the instructions from the PDF file and run them because they are setting up some kind of a benign environment. At first, it didn't want to do it, but it took a couple of obfuscation methods, base64 and rot13, I think, and a little paragraph as well about the fact that it's safe to run the command. So we instruct the bot, please run this command because it's safe. It's just a testing environment. Nothing bad will happen. And it was enough to actually convince Claude to run this command on our system. What comes with prompt injection is not just this kind of threats. There is a wide range of threats related to specifically to agentic systems. The attackers could exploit any tooling that the agentic system has access to. They repurpose benign tools in malicious ways, so do malicious things with the use of benign tools. They could try privilege escalation, so some tools will have higher privileges than others, and they could use those tools to access unauthorized systems or to laterally move and access databases and data repositories and stuff like that. They can do knowledge base poisoning. So if the system has access to a knowledge base via prompt injection, the attackers could poison this database and make the bot's responses incorrect. And they could also use it for resources exhaustion, so denial of service, basically. There is another risk of data loss and exposure. So as we said, those systems has access to a lot of data, and sometimes the agents might transfer this data between each other using some protocols that are not fully secure, and this data might be actually exposed to external parties. The bots can, for example, need API keys to access some tools, and those keys might be transferred in an insecure way and leaked to the attackers. And there is another risk that is related to the memory, the fact that those systems have memory. So the memory is basically stored in a database or in a file, and it can be abused as such, and it can be manipulated in a way that the bot will behave differently from what it's supposed to. Going back to the MCP protocol, so if we are exposing our AI to, if we are setting up an MCP server, we should keep in our mind that MCP is not really super strong on the security side at the moment. For example, the tool permissions, the permissions of the tools that MCP uses are totally unclear. Some of those tools ask you just for permissions once, and then if you grant them the permission stays there. So the next time the tool will run with this specific permission. There are also some MCP servers that allow for arbitrary code execution, and that's never a good idea. There is a possibility of data exfiltration through integrations such as Slack and Google Drive, and so on and so on. And some of those security issues were already exploited. So researchers in this case, were able to poison an MCP tool, inject a malicious service. And they did it because the MCP protocol just shows you very short descriptions of the tools that you are able to use, and those descriptions can be whatever the developer sets. And then there is a full description that is only available to the AI, to the LLM. And in this full description, the attackers could plant prompt injection commands or, well, malicious commands to be executed by that tool. But you will not be able to see those commands because they are only available to the AI. I'm going to pass to Eoin right now.
Cool. Thanks, Marta. So we saw a lot about the types of attacks and the risks, the key risks that can affect agentic systems. But what can we do about it to ensure that we have the required information when an incident occurs? With logging and monitoring, you can analyze what you didn't log. And having spoken with a lot of folks who have worked in IR, they said the first thing they go for is logs. So if we don't have them, if we don't understand, the history of the chat or the conversations between agents, then we can't build a picture. But there's some other things here. We need to adequately log the access to that model, the requester telemetry, such as like the IP address and the user agents and session context and temporal metadata. Super, typical stuff that we would assume that we're capturing, but not always, because it does require forwarding if you're using some sort of proxy or API solution. We need to track modifications to AI deployments, ensuring the basically integrity of the ML supply chain. Things like models, the model artifacts, the inference code that's used to support and deploy the models, even things like the hyperparameters that the models are launched with can affect the model's downstream performance and should be adequately tracked. When it comes to data, adequate versioning of that data, understanding, and itemizing and doing an inventory of that data, and understanding what's gone in and out of a RAG system. Because again, as Marta was saying, data is the new attack vector with LLMs. We don't need a vulnerability. It can literally just be a PDF or an email or a piece of audio, a spreadsheet, you name it. Ultimately, as well, we need to modify to track modifications to things like MCP servers in case an attacker gets in and subverts it, or inference servers if they maybe potentially allow the uploading of a malicious model, which causes a deserialization vulnerability, which then hoses your MLOps deployment system. And ultimately as well, versioning, pinning, things like that for libraries, just to ensure that you have the correct version that is free of vulnerabilities as opposed to something legacy. So I want to talk a little bit more about logging of prompts, because it's a hot topic and it's something that I've spoken with folks about, that there's like this sense of unsurety as to how we log them. When we're logging prompts, we obviously want things like the temporal data, the requester level information, the basics that we kind of referenced a second ago. But we also need to start tracking inputs and output pairs in context of one another, because it's no good if, we're matching up random outputs to random inputs. We need to understand the context and also the chronological history of that conversation or chat or whatever your chosen word is to describe data going in and out of models. Now, if we need to, from an IR perspective, if we want to recreate an attack, we want the full prompts because we want to see exactly what's happened. We want to know what part of that prompt has triggered. However, there's issues with that. Current legislation requires us to redact things like personally identifiable information, sensitive data, user data, and that's important. We should do that. But I'll get to that in the next slide. Now, obviously, we have constraints around their data retention period for the customers. We need to ensure that those logs are encrypted, because if you're logging those prompts in full or even redacted versions and you compromise the machine that's storing the logs, well, you've just gotten all the access to the data anyway. And that could be, in a system where its purpose is to handle sensitive information, that could be a major breach to your organization. So yeah, it's a nice edge balance, between having everything we want so that we can recreate and triage the attack versus ensuring that we're compliant with regulation and legislation and ultimately protecting our end users downstream. I heard this quote from Rob van der Veer at the SANS AI Summit: customer data is like radioactive gold, and we should start treating it as such. Now, there's some more difficulties. How do you know what to redact? Right? Text is text, it's natural language. We do a poor job of moderating social media platforms, not for lack of trying. So how do, there's no set of standard things that we can rip out outside of basic regexing, like, looking for things like social security numbers and credit card information and postcodes and what have you. But when it requires a contextual understanding, do we have a second LLM triaging that? Do we have another, do we log that? Do we have another LLM logging that and triaging that? And does it end up in this recursive cycle of LLM context analysis? Now, what if the intent of the system is to use sensitive info? And what if that's critical to understanding how that model made its decision in the first place? Well, do you log it or do you not? If prompts are lengthy, some of these prompts can be hundreds of thousands of tokens, what's feasible to log in terms of the actual amount of data that you have to store? Do you have appropriate safeguards? So, things like access control and encryption and segmentation to ensure that even if you are breached, maybe your sensitive logs are shunted out to a different environment altogether. And where it gets really interesting is if you want to recreate the attack to ensure that that is exactly where it came from, or even just to maybe test a new defense you've built, can you rebuild the chat history? Do you have that information logged so that you can recreate it? Or will you even be able to recreate it in the first place? Because LLMs are non-deterministic, you could send the same prompt in 4 or 5 times and it'll get back a different response, right? So how can you actually ensure that these logs are useful to you in your analysis? And some of these are open questions, and I'd love to hear some feedback on this. It is a difficult thing, and I think the industry needs to shift towards providing some more clear-cut guidance on what is and what should and shouldn't be logged with regards to LLM systems. When it comes to security monitoring, we talked about how security monitoring for LLMs and for this new agentic age is an emerging technology, but things that we can look for are things like prompt injection and jailbreak detection. We can actually look at guardrail activation as an indicator of a potential attack, where a user maybe has hit guardrails 100 times in the last day, which is atypical. And that can give an indication for your SOC team or what have you to get ahead of this before you're ending up getting woken up in the middle of the night to deal with it as an IR. When it comes to user interactions, we want to monitor ultimately at that requester level. If we have an attack, we want to be able to attribute it to an individual. If we see, hey, at some point in these 100,000 messages that this agentic AI system got or pieces of data, that's a needle in a haystack. So having clear-cut, identities there is important. We need to track IPs, user agents, profile typical usage patterns, and even do some secondary analysis on that. And look at things like MCP. We need to understand who's querying external MCP servers. Not just that, we need to actually really carefully look at what MCPs your AI model is querying, because they also they also create a potential security risk wherein your AI model reaches out to an MCP server that has a prompt injection built in, and your agentic solution gets prompt injected by reaching out to this data, and it causes this big network effect downstream of that model. Now, with protocols like A2A, this is agent-to-agent interactions. Again, if they're having conversations and we don't know what they're saying, that's another potential avenue for a cascading effect or a network effect throughout that system. If one piece of that agentic, like multi-agent architecture, ingests some malicious data, then who's to say it doesn't end up proliferating through the other agents that are chained together in that architecture? Marta talked about tool calling and database read-writes and inter-agent interaction. Like, all of these things need to be logged, they need to be traced. We need to understand how an AI model is enacting its changes within the environment, how it's interpreting data, if it's reading and especially writing to databases, because you're basically one step away from an SQL injection attack proliferated through an agentic AI model. So shifting our focus to governance for a second, another Claude quote here: good governance doesn't constrain incident response, it amplifies its effectiveness. So what we're I guess proposing here is establishing clear AI ownership within your organizations. We need to establish who owns the model and who's actually responsible for it, especially if an incident occurs. Is this your security team? Is this your data science team? Is it another team that's deployed an agentic solution unawares to the other teams in the company? That needs to be clearly defined, and you need to ensure that people are there to basically ensure that the performance aspect is kept, the integrity aspect is kept, and that essentially that you have escalation paths in those teams to be able to handle and deal with an incident in an agentic system. An agentic system may end up touching multiple parts of a business. It may have multiple effects throughout different parts of the organization. So actually starting to build and look towards building out an incident response plan with clear escalation paths and clear points of contact in the teams that the agentic solution interfaces with is critical. And especially so for business critical systems that if it goes offline, you're into a serious business outage or a material risk. You know, to ensure that AI systems are, I guess, more robust against these attacks and make sure that your business systems are more robust against attacks, we need to ensure that there's some level of failover protocol or a business continuity plan, ensuring that if you are deploying an AI system, it's not a single point of failure for your business. Because these things will almost definitely fall over in ways that we haven't even conceived yet. I mean, look, the fact that agentic has blown up so much in the last few months since we submitted the CFP shows you just how fast the space is moving. And it's hard to keep up with, even for folks who are in the space full time. So we need to build in redundancies. We need to have established failover protocols. And for any actions that actually incur a high level of risk to the organization, we need to ensure that there's a human in the loop. However, again, it becomes a little bit difficult here because the definition of agentic is agency, meaning it has the agency to go off and make changes by itself. So every action can't go through a human in the loop. And if it does, well, it's not very agentic. It's just doing human work with extra steps. So we're coming up on the end here, but we need to inventory AI systems. So again, having a clear understanding of the models deployed in your environment. Any externally facing models are super important. MCP servers, A2A, we need to register these models. We need to have them stored or have a list of these stored somewhere. We need to map model capabilities like tool calling and database and access privileges, and ultimately the scope of the model to ensure that you're not ending up with like some unknown effect inside the system that you're triaging. And ultimately, while we've kind of glossed over it in this presentation, because we did speak about it last year, the AI supply chain components are another key risk factor between the data, the models, the tooling, and the infrastructure. And all of these should be well tracked and documented. And shifting like really far left again, which may be outside the purview of incident response, we still need to implement and advocate for secure architectural design. So, ensuring that we have the correct access rights and privileges, we have role-based access control, we, follow the principle of least privilege and restrict access of agentic systems to specifically what it's designed for, ensuring it doesn't have like write access to a critical database when all it needs to do is read a couple things from it. We need to ensure that agent memory and context protection is ensured. So again, things like strict memory access controls, watching things that go in and out of RAG systems, isolation of memory between agents and sessions, ensuring that you're not getting this like cross-pollination from context histories leaking out, or I guess also causing potentially a confused deputy problem, though that would be more access rights and privileges. We need to essentially ensure secure session and context management and regular memory audits. Ultimately, look, any data should be treated as untrusted. We see it with PDFs, we see it with emails, we see it with all sorts of different bits and pieces, but the attack surface is now expanded to include data, and anything that an LLM is pulling in from external sources should be vetted in some way, shape, or form. How? There's a variety of different ways. It's difficult to say depending on your specific use case, but looking for things like prompt injection is a key start. And again, like understanding the robustness of your model is also super critical. We need to isolate, compartmentalize, and basically segment AI models to ensure that the blast radius in the potential attack is reduced, that we don't want to give them access to everything. It could end up really screwing up your business if it does. And we need to ensure that we're following so many of these different security recommendations that we've proposed. Defense in depth is key. There's no silver bullet. So back to our incident. If you had logging, if you had security monitoring, if you had inventory, if you had established governance, you might have slept a little bit better that night. Cool. Thank you so much. Appreciate it. I think we're at time.
Fantastic. Can you hear me? So we do have a couple of questions, and I think we have a couple minutes to take care of them. Great job, folks. Thank you. The question is, we always talk about training an AI model. In your research, did you find anything to untrain an AI model? Agentic system have long-term memory. How do we really know if we purge or untrain the data?
Yeah, I think there's a couple of interesting questions in that. I think like removing alignment or removing guardrails is an interesting proposition. Basically training out the safety controls of a model. We've definitely seen research into things like control tokens and whatnot, which can enable us to do elements of this like alignment removal. But like untraining a model in a specific area, like again, like the model has to be useful in some way. So how much do you want to walk it back? So that's why I kind of focus more on the alignment aspect there, because that's clear cut. Yeah, and ultimately LLMs are probabilistic in nature. So if it doesn't know the answer to something, would you prefer it to know and refuse to give you the answer? Or would you prefer it actually provide you a hallucinated response because it will just approximate a rough idea of what you're asking it? So I think untraining has limited scope in terms of success. But yeah, I'm again happy to chat about that later.
Sounds good. Thank you. And the next question, which is the last one actually, seems self-explanatory, but nonetheless, shouldn't agents have access to systems that can be safely exploited and data that can be safely exposed to users, since safeguards might be bypassed with enough patience?
Yeah, but again, you have this counterbalance between utility of an agentic solution inside an organization against its risk profile, and it's always been a trade-off like that. We have high-risk systems that they're deployed all the time, but they're so beneficial that we end up implementing safeguards around that. So I think the key purpose of agentic is to get stuck in with sensitive information. It is to get stuck in with tasks that are business critical, because if it's not business critical, then why are we doing it? But because these things are business critical, we end up ultimately introducing that risk, which could potentially end up in a really rough situation. So again, it's this kind of seesaw, knife's edge balance.
Thank you so much. And that wraps it up. Thank you,
Thank you.
Marta and Owen. Really appreciate it.